Hey guys, welcome back to the next video. In this video, we are going to talk about what is Kubernetes. Now, remember that before you start this training, it is always recommended to understand what is a container. So to better understand about the container, you can go and watch the previous video on containers, and you can watch this Kubernetes after that. I hope you would have watched what is the benefit or what exactly understanding Kubernetes on the previous video, just giving you demo about those which is possible with Kubernetes. Now here in detail, we're going to see Kubernetes. And the first thing to start with is what is Kubernetes. Now, Kubernetes is a popular choice for container orchestration. Now, what is container orchestration is to control the containers and do a lot of automations with that. Like you will be assigning Kubernetes to manage those containers. That basically is orchestration or orchestrator in this case, that handles these container-related tasks, like, for example, deployment, rollouts, service discovery, storage provisioning, load balancing and scaling, self-healing for high availability. Likewise, it will do all those things. So let's see each of these components in little detail so that I open up the further topics down the line. First one is the deployment, right? Kubernetes deploys a specific number of containers to a host and keeps them running in a desired state. So that's very simple. That's basically called deployments of containers. So now, if you're coming from WebSphere background, deployments could mean that a web application or enterprise application deployment. It's not about that. Deployment here in the container world is deploying a container and having that running. So that's basically is deployment. The next one is rollout and rollbacks. A rollout is a change or to a deployment, as in like whenever there is a new versions of your application updated in that, you can actually have a container, replaced. We will see in detail though, with the latest version of the application. And also Kubernetes lets you initiate, pause, resume, and even roll back those rollouts. So which means that going back to the previous version, so that is also possible in terms of working with Kubernetes. The next one is service discovery. In terms of Kubernetes can automatically expose a container to the internet or to other containers using DNS names or IP address. So which means that your service is not just hosted within itself, but also it's widely available. In terms of storage provisioning, you can set Kubernetes to mount persistent local or cloud storage for your container requirements. In terms of load balancing and scaling, when traffic to a container spikes, Kubernetes can employ load balancing and scaling to distribute it to networks to maintain stability and to increase the number of instances which is going to serve your request. So that's scaling. Self-healing for high availability. When container fails or it just hangs or any kind of disruption happens, Kubernetes can restart or replace it autonomously. It can also take down containers that doesn't meet your requirements or health requirements, which making sure that the high availability is maintained. Developers' choice how Kubernetes is gonna function. So it's basically how you set up and you set a standard for Kubernetes to operate and work in a growing ecosystem of open source supporting tools. And it supports portability across the leading cloud providers such as Google, AWS, and Azure. So that's so much for understanding what is Kubernetes. So let's just go and understand what is Kubernetes architecture or clustering architecture. Now, clusters are the building blocks of Kubernetes architecture. Clusters are made up with nodes, each of which represents a single compute host that runs containerized application. Very simple. Nodes host the pods. Now, these pods are basically the components in which the workload is being done. So as you can see in the in this architecture over here, so you have the infrastructure, either it is a physical, local, cloud, or on your laptop, doesn't matter. So you have this something called control plane. Sorry about the typo over here on the spelling, so just bear with that. So control plane is over here. This is the central controlling nerve system of your Kubernetes. So all those orders or execution plans will come from control plane, and then it goes to the pod. We will see in much more detailed architecture later point of time, in which you will understand what are the components of control plane and what are the components of your data plane, which is your pods. So what this means is that the control plane manages the node and the pods in the cluster. It schedules container onto nodes according to the availability, capacity, and user-defined configuration. So that's basically what the control plane does. So this is a very simple architecture of Kubernetes cluster architecture. But then we will go into some details in terms of control plane over here. So now here, the architecture expands a little bit, where you see the control plane comes into life by talking about different modules here. So let's go ahead and understand about this. The control plane component makes global decisions about the cluster. For example, scheduling. Okay, so what the scheduling does is basically it first verifies an existing pod, whether the appropriate resources are available, and then it does the scheduling for those new container creations on a specific pod, or creating a new pod itself for that matter. So that's basically what the scheduler does. So just that one example, because there are other components in your control plane, but I'm just giving you for an example. So the control plane components can run on any machine in a cluster, but typically runs on a dedicated host. That's what is recommended. The Kube API server is the front end of the control plane and exposes the Kubernetes APIs. It is designed to scale horizontally, that is, scale by deploying more instances. You can run several instances of Kube API server and balance traffic between those instances. Now, all this Kube API server is going to do is to manage the clusters. Having multiple numbers of Kube API will be effectively managing the cluster faster if there is a requirement to do so. The next component is etcd. etcd is typically the backing store for cluster data. It holds the information about your complete cluster. All right. So what information it holds? Basic informations like what is the cluster state, what the clusters are doing, and where it is hosted, what devices are connected to it, likewise like storage devices, The Kube scheduler the Kube scheduler considers available resources and determines where in the cluster to place the new pod. So likewise, I told you before as an example. Kube controller manager runs several controller processes that are compiled into a single binary. These includes node controller that detects and responds to node failures, replication controller that maintains the correct number of pods for every replicated controller object in the system. Okay, so now you would have mentioned how much amount of repli set you need to maintain. So those things will be controlled by that. An endpoint controller that populates the endpoint object, that is the connection of the service and the pod, and so on. Likewise, you have many other controllers as part of your controller manager. Now, there are two controller managers over here, the Kube controller manager and cloud control manager. So control manager can be either of this. So wherever you're connecting it from the cloud management, so it will be using cloud control manager. If you're using from the local system, so that time you can use Kube control manager, likewise. The control manager embeds the cloud-specific control logic that links your cluster into the cloud provider API, as I told you earlier, and separates the component that interacts with the cloud platform for components that is interactive with the cluster. So that's much about the control plane. Let's talk about the data plane. So the data plane includes what is called the node component. Okay, so the worker node component is how your masters will be executed. So as you are executing these orders from a master control plane, the worker control plane executes those orders which is coming in from the master control plane. Now, each of this, like either it could be a scheduler, it could be the controller who is issuing the commands, it will be ending up in something called kubelet. So let's discuss in detail. Node components runs on every node. Maintain running pods and provide the Kubernetes runtime environment. So this is basically the utilization of your node components. Pods are a group of containers that shares the same compute resource and the same network. Each pod has its own IP address, shares PID namespace, that is process ID namespace, network and host name. Pods are also the unit of scalability in Kubernetes. If a container in a pod gets more traffic, then it can, if it gets traffic more than it can handle, Kubernetes replicates the pod to another cluster, whichever the scheduler does that, and the scheduler looks at which node component or the worker node is free, or the resources in the worker node is free, and then it creates dynamically the pod there, and then sends the traffic to that new pod as well. So it does this intelligent management, and it through this intelligent management, it will be able to scale up and scale down your number of pods it has for that particular application. The kubelet is an agent that runs on each node in the cluster, which should be running on the worker node or the node component as a node component. The kubelet takes a set of pod specifications that are provided through various mechanisms and ensures that the container described in the pod specifications are running and healthy. The kubelet does not manage the container which were not created by Kubernetes. So that's something you should remember. So kubeproxy is a network proxy that runs on each node and implements part of Kubernetes server concept. It maintains network rules on nodes. These network rules allow network communication to pods from network sessions inside and outside of the cluster. kubeproxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kubeproxy forwards the traffic itself. The container runtime, which is the CRI Docker here, it says at this moment you can use this Docker CRI, which is container D, or else there is also alternative like Cryo. You can use Cryo as a CRI as well. So that's an alternative available for you. And mostly in our training, we'll be using Cryo. So that's the container runtime, which actually does all these container creation within a prod. Yeah. So that's the one it is sending those instructions to. As you can see over here, when you see the flow, you can see that the instruction goes to the agent kubelet, and then kubelet connects to the kubeproxy to enable the proxy configuration, and sometimes directly connected to CRI if it doesn't require any kind of a network configuration done. And it ensures the availability of the container, or if this previous one, right? So if the controller wants to do some activity on the prod, it basically goes to the CRI eventually and get those done. So it is not the Kubernetes which actually modifies the containers, it is the CRI. So without CRI, it's not possible. So within CRI, you will have OCI, and OCI will help you to do all the operations. Now, you know what is CRI and OCI. We have seen that before. But if you're not sure about CRI, hold on. There are some architectures coming up which can help you understand a container runtime interface. Well, the next point we are going to discuss is the deployment. So this deployment here, as I told you earlier, this is not your middleware deployment, which we are speaking about. This is container deployment. So deployment control that creates and states the container application and keeps it running. It specifies how many replica of a production should be running on a cluster. If a pod fails, the deployment creates a new one. So that's the process of the deployment. You can define the deployment to create replica set. A replica set is a set of pod templates that describe a set of prod replicas. It uses a template that describes what each pod must contain. The replica set ensures that the specific number of prod replicas are running at any time. So that is the whole sole work of deployments. You can also revise or remove deployments and deploy all the resources on the new deployments. So that's also an option which is available. When you reverse a deployment, a replica set is created that describes the state that you wanted. During the rollout, the deployment controller changes the actual state that you want to have this controller rate. Each deployment versions can also have a rollback as well, and rollback will leave the deployment in the previous version of whatever the version it was previously. So the rollback works without any kind of downtime. So the major reason why you have deployment is, to summarize, one is to make sure that you do the version upgrades and rollbacks. Another one is to maintain the replica set, and when you're moving or removing or revising the deployment, so it's make sure that those number of replica sets are always maintained. So that is what it is. So let's just go to the next one, which is namespace. So just give me a. So as this video is going for a long time, so I'm going to take a break. My throat is almost gone. So what I'm going to do is, like, I'm going to continue this video on the next part. Part 2 I'll make for the same, because there's just 3 more topics are there. So I'll just take a break, and then I'll make this video on the next 3 more topics towards this. Thanks again for watching this video. I will continue with the namespace, networking, and the Kubernetes command line on the next video. Thanks again.